Controlling the power of black hole. Theoretically speaking, controlling the power of a black hole is an incredibly challenging proposition, given their immense gravitational forces and the extreme conditions within their vicinity. Black holes are objects of immense mass and density, and their gravitational pull is so strong that not even light can escape their grasp. Currently, our understanding of black holes is limited, and we are still exploring their properties and behavior. However, there are some theoretical ideas that have been proposed for harnessing or controlling the power of black holes, although their feasibility is uncertain and would require advancements in technology and understanding. One idea is to utilize the rotational energy of a spinning black hole. The concept involves extracting energy from the rotation of a black hole by means of the Penrose process, named after physicist Roger Penrose. This process involves dropping matter into the black hole's ergosphere, a region just outside the event horizon where space and time are significantly distorted by the black hole's rotation. By exploiting the rotational energy, it may be possible to extract power in the form of gravitational waves or through other mechanisms. Another theoretical concept is the creation of a black hole-powered engine known as a black hole starship. This idea proposes using the immense gravitational pull of a black hole to propel a spacecraft. By controlling the flow of matter into the black hole and utilizing the resulting energy, it is theorized that such a spacecraft could achieve incredible speeds and potentially explore distant regions of space. It is important to note that these concepts are highly speculative, and significant scientific and technological breakthroughs would be required to realize them, if they are even possible at all. The extreme conditions and forces near black holes present enormous challenges and risks that need to be carefully considered. As our understanding of black holes and the laws of physics continues to advance, new insights and possibilities may emerge. However, at present, the idea of controlling the power of a black hole remains largely in the realm of theoretical speculation. Let's come to another point. Using black hole to bend time. Theoretical studies suggest that the extreme gravitational forces near a black hole could potentially influence the flow of time, allowing for the bending or warping of spacetime. This concept is rooted in Einstein's theory of general relativity, which describes how matter and energy curve the fabric of spacetime. According to general relativity, the presence of a massive object, such as a black hole, can create a deep gravitational well. As objects move closer to the black hole, they experience a stronger gravitational pull. This gravitational pull affects the passage of time, causing it to slow down relative to observers farther away from the black hole. Near the event horizon of a black hole, where the gravitational pull is exceptionally strong, time dilation becomes significant. Time dilation refers to the phenomenon where time appears to move slower for an observer in a strong gravitational field compared to an observer further away. This means that time would pass more slowly for someone near a black hole compared to someone far away from it. The concept of time dilation near a black hole has led to the idea of using black holes for potential time travel scenarios. If it were possible to approach the event horizon of a black hole without crossing it, an observer could experience time passing at a different rate compared to someone further away. This time difference could allow for scenarios where an individual near a black hole might experience time passing more slowly, effectively traveling into the future relative to the external world. However, it's important to note that the extreme gravitational forces near black holes also create significant challenges and risks. The tidal forces near the event horizon are extremely powerful and could tear apart any physical object. Additionally, our current understanding of black holes and the laws of physics is limited, making it difficult to predict the exact behavior and implications of using black holes for time manipulation. The concept of using black holes for time travel remains purely theoretical at this point, and much more research and understanding are needed to explore its potential feasibility and implications. On another theory, we try to create a star in a jar and destroy it to make a black hole. Creating a star in a jar and then causing it to collapse into a black hole is not a feasible process with our current understanding of physics. Stars are incredibly massive and complex objects that form through gravitational collapse of clouds of gas and dust. The energy and conditions required to initiate and sustain nuclear fusion, the process that powers stars, are beyond the capabilities of a jar or any controlled environment we have. In order to create a star, you would need a vast amount of matter and energy, as well as the right conditions of temperature, pressure, and density. These conditions are naturally found within the vast clouds of gas and dust present in space, where stars form over millions of years through gravitational attraction and the subsequent fusion of hydrogen into helium. Even if it were somehow possible to create a miniature star within a jar, causing it to collapse into a black hole is not a straightforward process. The formation of a black hole typically requires the core of a massive star to collapse under its own gravity after exhausting its nuclear fuel. This collapse creates a gravitational singularity, a point of infinite density, surrounded by an event horizon from which no light or matter can escape. To replicate such conditions artificially and create a black hole within a confined space would be immensely challenging, if not impossible, with our current technology and understanding of the laws of physics. Black holes are formed through natural processes in the universe involving enormous masses and energies. It is important to approach these concepts within the framework of scientific understanding and recognize the current limitations of our knowledge and technological capabilities. While the idea of creating and manipulating stars and black holes may be intriguing, it remains largely in the realm of science fiction and theoretical speculation at this time. If the black hole controlling works, we can make it work in many ways. For example, forming a wormhole. The idea of using black holes as wormholes for interstellar travel has been explored in theoretical physics and science fiction. However, it's important to note that the current understanding of black holes and wormholes is limited, and the feasibility of using black holes as practical wormholes remains uncertain. Black holes are objects with extremely strong gravitational forces that result from the collapse of massive stars. They have an event horizon beyond which nothing can escape, including light. Inside the event horizon lies a gravitational singularity, a point of infinite density. Wormholes, on the other hand, are hypothetical structures that connect different regions of spacetime. They are often depicted as shortcuts or tunnels that could potentially allow for faster than light travel or travel between different parts of the universe or even different universes. According to some theoretical models, it is speculated that under certain conditions, a traversable wormhole could be formed using exotic matter with negative energy density to stabilize and hold open the throat of the wormhole. However, the existence of such exotic matter remains purely hypothetical, and we have not yet discovered any direct evidence of its existence. Furthermore, even if traversable wormholes were theoretically possible, using black holes as wormholes would require overcoming significant challenges. One challenge is that the extreme gravitational forces near black holes make it difficult to traverse them without being torn apart by tidal forces. Additionally, the stability of wormholes is a topic of ongoing research. Wormholes are believed to be highly unstable and prone to collapse or require immense amounts of energy to keep them open. Theoretical physics has not yet provided a clear understanding of how to create, stabilize, and traverse wormholes effectively. While the concept of using black holes as wormholes is intriguing and has captured the imagination of scientists and science fiction writers, it remains an area of active research and speculation. Future scientific advancements and breakthroughs may provide a deeper understanding of black holes, wormholes, and the possibility of utilizing them for interstellar travel, but for now, it remains a theoretical possibility rather than a confirmed reality. Thanks for hearing the thoughts. Have a great day.